Welcome to the presentation of the integration between Altium Designer and SAP's Engineering Control Center with integrate2. Based on the ECTR platform, Integrate realizes an intuitive integration for ECAD design applications. The handling of the tool environment is quite simple and intuitive. At the beginning, we shortly introduce the advantages of an integration between Altium Designer and SAP's ECTR platform. Afterwards, we walk through a typical design flow. In the first sequence, a new design is created. Subsequently, the design is saved into PLM. And as soon as your design is reached in status where the generation of the bill of materials or production data is helpful, this step will enable you to produce this data easily with the aid of Integrate. This data will be saved into PLM too. We will have a look to the data in SAP's ECTR platform and SAP PLM in sequence 3. The important step of library synchronization between your development library and the library information in SAP will follow in sequence 5. Finally, we shortly refer to some additional functionalities of Integrate. Integrate2 helps design engineers with all relevant steps dependent to a product lifecycle management system. This enables on one hand the possibilities of a central, consistent and company-wide identical management and exchange of design and component data. On the other hand, the development engineer can handle all necessary steps directly in the ECAD system itself. This includes standardized, configurable process flows and the easy handling of design templates. The advantage of the usage of design templates will be explained more deeply later on. Workflows are automated, for example, the generation of the bill of materials, a consistent check of it with the data in PLM, the generation of the PCB and pick-and-place information, and the transfer of those data to the PLM system are included. Although the synchronization of the component information between the development library and the product lifecycle management system is a very important issue. Within that, not only misunderstandings or double work can be omitted, but also real process stabilization is reached. Within all that step, Integrate can be individually adapted to your company needs. Finally, Integrate will speed up your design process and your product management. Out of that, you will not only save time and money, but will increase your process reliability. Integrate is integrated in the well-known environment of the development engineer. All actions are taking place from here. In this case, Integrate is placed into the menu of Altium Designer. The different modules are containing sub-functions which can be individually adapted based on customer needs. This offers the possibility to respect company-specific processes. In this demonstration, we will show a typical way how Integrate is used in a characteristic workflow of a development. We start our development with the creation of a project. This is typically the first step. Right now, there is not any object existing in PLM for our design. The interface of Integrate is grouped in 3 main areas. The first one handles aspects depending on the project itself. In this case, that includes the project name and the target directory. In the second area, the starting point for our new design is selected. Integrate is offering different possibilities for that. On one hand, the starting point for a new design could be an existing design. This design could either be selected from a network drive or either from the PLM system. On the other hand, we have the possibility to select templates which was saved on the network drive or in PLM before. The storage in the PLM system opens up the possibility for version-controlled and company-wide defined templates. In this way, also templates can be handled in an own lifecycle. In our demonstration, the template coexists out of a schematic and a PCB template. In addition, we assume in our demonstration that the PCB technology is already known and can be selected from the beginning. Our design will be stored on the file system. In our example, the schematic diagram and the PCB layout contains already designed elements. The template has in addition output job configurations. This will be executed from integrate to create, for example, PCB fabrication and assembly data. This way of working offers not only the possibility to create company-wide uniform data, but also to predefine necessary parameters for that in advance. If needed, the design engineer has still the possibility to adjust those formats. Our created project contains 2 design variants. We will have a closer look to that later on. Up to now, there are still no elements existing in our PLM system. To push the design into the PLM system, the module save is used. 3 important areas should be mentioned in this module. The first one contains functionalities round about the project itself, including the design container and assembly variant independent schematic drawing and the release aspects. In the next part, the PCB is handled, including its fabrication data. Finally, we see an area which handles all variant-specific data, including variant-specific schematic drawings, pick-and-place files, and bill of materials. In this demonstration, we assume that the development engineer has the possibility to create all objects within the data model. If that would be not the case, he could use the search functionality to search and select existing elements in the product lifecycle management system. Instead of creating each element one by one, the button Upload All could be used. It would create all elements and set all checkboxes in addition. Only the checkboxes Release and Keep Reserve are not touched by this button. Those can be selected or deselected based on the actual process flow milestone. It is possible to continue with the design process, hand over the design to somebody else, or handle release aspects. Based on company needs, the release checkbox could, for example, just release the design container, release all created elements, or starts a release process within the PLM system. Let's have a look to the edit buttons. One can be found for the PCB and one for the different assembly variants. Those provide us additional frames to view and edit further information regarding those elements. For example, the PCB edit button could be used to fill additional README files for the PCB manufacturer. The Show buttons enable us to open the created elements in the PLM system. In our example, the Show buttons are configured to open the different elements in SAP PLM directly. Alternatively, they could open the elements in SAP's ECTR interface. If wished, Integrate could have also 2 Show buttons, one for SAP PLM and one for SAP's ECTR platform. We start the save process with OK. Now the module will create the structure in the product lifecycle management system. Vice versa, metadata is transferred into the design. We will show that later on. In addition, the module will produce PDF files, PCB fabrication and assembly data. Now a BOM comparison report is opened. The information on the different tabs is highlighted with different colors. The first tab contains an overview of the different assembly positions. In this case, all lines are green, because we are transferring our data the first time. All elements are new. If the module will be executed again, the colors will change. The new color will depend on the status of each individual component. It could be that it is new, has been changed, has been deleted, or is just as it was before. The quantity view is shown in the second tab. In each individual line, a different component type is listed. The amount of components and the assembly positions are listed as well. The next tab lists missing components. Those elements are not existing in the PLM library yet. Depending on our company process, the module will stop in such a case or just produce a warning like in our demonstration. Not yet or not any more released components are listed in the next tab. The next to last tab contains those elements out of the design which have neither an ECAD nor a PLM identification number yet. Finally, and the last tab, are those elements listed which are relevant for mechanical engineers. The process will continue after pressing the OK button. As already mentioned, we receive in our demonstration a warning because of the missing components. In our case, we can ignore that. Now Integrate will upload both assembly variants into the PLM system. It creates variant-specific schematic drawings, pick-and-place files, and transfers them into the PLM system. Also, it will create Gerber files, the drill plot, and saving all those to the product lifecycle management system. Because of the automation, the save process is really simple. After the setting of the relevant checkboxes in the save module, all data is created and uploaded with just one click. Let's have a look to our SAP ECTR interface. We search for our documents with the search function and we'll have a look to the different created PDF files. In the link to the design or innovation container, we find the variant-independent schematic drawing. In the drawing frame, we find updated metadata information. As in all other example files, further metadata can be configured in addition. The PCB document item contains the drill plot. For each variant, two PDF files were created. The first one is the assembly plot. The second one is the variant-specific schematic drawing. We now use a material search to have a look to one of our bill of materials. The bill of material window shows us not only a quantity view, but also each single reference designator is listed. Finally, we use the show buttons in our integration to open some of our produced zip files directly in SAP PLM. Therefore, we start the Save module. For example, the Show button of the PCB document opens the PCB document in SAP. Besides the drill plot, we find the zip file containing the Gerber files. To view the documents of a design variant, use the related document Show button. Here we find a zip container containing a pick-and-place file. The shown data structure is of course just an example. The individually structure for your company can be adapted to your needs. Now assume that our design was already released. Because of new requirements, we need to make some changes at the design. Start with the module Checkout to open the existing project. The search dialog enables us to search for the existing design. In this case, the user interface offering the search via ID or name. Additional search parameters can be added on demand. After confirmation with the OK button, the design is downloaded and renamed according to the new revision and the identification number. The next step would be now to change the design and upload it again with the module Save to the PLM system. Therefore, we delete two capacitors and place a new resistor into the design. After that, we start the module Save once again. In our case, the changes in the bill of materials is now the main point of interest. Therefore, we just select the bill of materials for the relevant two variants. Again, we see a BOM comparison dialog, where we now can see the difference to our last version. The two deleted capacitors appear in the reference designator view as removed components. In contrast to that, the new resistor is listed in the Missing Parts tab, because we have placed a part which does not exist in PLM yet. In our case, the warning message can still be ignored. Another important functionality of Integrate is the synchronization of the development library with the library in the PLM system. This will enable you to keep both sides consistent. It's important to know that it doesn't matter if you want to place the new information first into the development library or into the PLM library. The synchronization can take place bidirectionally. Also, component-specific parameters can be exchanged. In our demonstration, we are just defining a new component inside the Altium Designer library. That component will be synchronized with PLM later on. Some companies organize their components in the development library with the same identification number as in the PLM system. Other companies have an ECAD-specific identification number. Out of that, we use for our demonstration a separate field or parameter in the development library containing the identification number of the product lifecycle management system. This number will be assigned in the PLM system and synchronized with the development library via Integrate. Now we start the synchronization of the components. In our configuration, the integration asks the user first if you want to load the missing parts from the last BOM upload into the synchronization window. As a second possibility, the selection of parts for the synchronization is possible via the defined component classes. The components shown here are marked with different colors. The blue color is indicating that the parameter information in the development library is different to the one in the PLM system. Green marked components are not existing in the PLM system yet. Therefore, the column of the PLM system is empty. Black marked components are already synchronized. In difference to that, red marked components are not existing at all in the development library yet. If we start the synchronization, the selected component is created in our PLM system. Vice versa, the created identification number is copied to the development library. Also here, we have the possibility to open the component item in SAP PLM or in SAP's ECTR interface with the help of the Show button. Please be aware that the synchronization direction can be defined individually for each parameter within the configuration of Integrate. Also, component-specific parameters can be included in the synchronization. In case a status change would now happen in the PLM system, the information will be updated in the development environment according to the defined update cycle in your company. There are different possibilities how that update could take place. The first manual one we have demonstrated in this video. As a second possibility, an automated periodical batch run could take place, for example every night. Also, the status change of a component in the PLM system could be a source of synchronization. Other events inside the PLM system might be also a trigger for an update. Besides the shown elements, Integrate offers further functionalities. The features from mesh and to mesh enable the user to exchange mechanical relevant data with the MCAD team. IDF and step files are some well-known examples in this area. New Project with PLM offers an alternative way to create a new project. Here we will find on one hand the functionalities for creating a new project like in the module New Project. On the other hand, the functions from the Save module to create or select structures in PLM are placed here. Out of that, the project will be mapped to the relevant structures in PLM right from the beginning. Last but not least, the feature New PCB should be mentioned. In the beginning of that demonstration, we created a new project with a schematic drawing and the related PCB technology. There might be the case that the PCB technology is not known right from the beginning. Therefore, the schematic engineer might start only with the schematic and add PCB with the feature New PCB later on. As you could see, Integrate realizes a real coupling between your development environment and your product lifecycle management system. On our homepage you can find further information for this and for other products and services of XPLM solutions. Please feel free to contact us. Our contact information can be found on our homepage too. It would be a pleasure for us to meet you.